This is the course plan of Form 613, Biopharmaceutics and Pharmacokinetics. Fourth year, I think it is morning or evening, I don't know which lab. Well, uh, the books which we prefer for the practicals, these are all the same which we have followed for the 611, Biopharmaceutics and Pharmacokinetics. Alton, Leon Chorgel, Applied Pharmaceutics and Pharmacokinetics. And the third one is the Biopharmaceutics Application in the Drug Development by Rajesh Krishna. These three books are available in your library, and as well as I have already uploaded on HULMS system. Total 10 experiments. As you can see in this course plan, first, this is not the experiment, but it is the introduction to the biopharmaceutics, pharmacokinetic number 1 experiment. This is the determine the disintegration time of uncoated tablet. Second, determine the disintegration time of enteric coated. Number third, determine the disintegration time of film coated. Next one is the disintegration time of sugar coated tablet. Number fifth, determine the disintegration time of capsule and so on. This is the course plan available on HULMS system. You can see from there. Okay, we start our first experiment. But going to the first experiment, it is necessary to know about introduction of biopharmaceutics. This is the introduction of biopharmaceutics, as we have already learned in 611. What is biopharmaceutics? Biopharmaceutics examine the interrelationship of the physical chemical properties of the drug, the dosage form in which the drug is given, and the route of the administration on the rate and extent of systemic drug absorption. Biopharmaceutics just links the physical and chemical properties of the drug and the drug product to their clinical performance. Clinical performance means in vivo. What the drug do with the body. Consequently, a primary concern in the biopharmaceutics is the bioavailability of the drug. Some physicochemical properties are considerable in the drug product design. What are these? These are number 1, pK and pH profile, polymorphism, hygroscopicity, partition coefficient, excipient interaction, pH stability profile. It's whenever we are developing a formulation, we must consider its physicochemical properties. These are the some, but there are more physicochemical properties which we have a deep concern whenever we are developing a drug product or designing a drug product. Bioavailability, it's referred to the measurement of the rate and extent of active drug that become available at the site of action. For the majority of the orally administered drug, the site of action is within the systemic circulation and the drug must be absorbed to achieve a pharmacological response. A drug product may also be designed to deliver the drug directly to the site of action before reaching the systemic circulation, which is often termed locally acting drug like cream, ointment. Some example of the product in this class include ophthalmic, pulmonary and a nasal drug product. They are producing their localized action and then they proceed to the systemic circulation. So, what are the factors that influence the bioavailability? Various physiological factors reduce the availability of the drug prior to their entry into the systemic circulation. Number one, drug is taken with or without the food will also affect the absorption. As we have read or we see that most of the drugs have some food interaction, like tetracycline, have an interaction with the milk, and milk contain the calcium. They make some chelating agent, as we have read, and we have seen some people have the decolored teeth. This is the side effect of the tetracycline. Other drug taken concurrently may alter the absorption. I mean, definitely, when in geriatric patient, polypharmacy is very common. Too many drugs are taken at a time, so there may be a chance of interaction that one drug increase the bioavailability of other or decrease the bioavailability of the drug. In this case, the drug may be a toxic in case it increase the concentration and may be ineffective if it decrease the other's drug concentration. Number third, first pass metabolism. Intestinal motility alter the dissolution of the factor. Disease state affecting the liver metabolism and gastrointestinal function will also have an effect. There are other factors also influence or affect the bioavailability are physical properties of the drug, like its hydrophobicity, pK, and stability, which we have already learned in today's lecture, the factor affecting the bioavailability. So these are the factors. And the drug formulation, whether the drug is immediate release, which kind of excipient is going to make such formulation, or you can say what kind of the excipient the pharma industry is going to use in such drug. Manufacturing method के किस मैन्युफैक्चरिंग मेथड के जरिए से किसी भी ड्रग को फॉर्मुलेट किया गया है. These are all the different factors which influence the bioavailability of a drug. Factor influencing the bioavailability. Okay. Some rate limiting steps in different formulations are to be considered. For example, for the solid oral immediate release product, tablet and capsules are the solid oral immediate, maybe immediate or extended, it's maybe, but it is the oral solid dosage form, tablet and capsule. The rate process includes disintegration of the drug product, dissolution of the drug, and absorption across the cell membrane into the systemic circulation. If these three factors are the rate limiting step for any oral solid dosage form. The slowest step in a series of the kinetic process is called rate limiting step. This is the definition of the rate limiting step. वो step जो कि किसी भी kinetic process को slow कर वो the drug that have very poor aqueous solubility, what do you think? What it will happen for the drug that have very poor aqueous solubility? The rate at which the drug dissolves is often the slowest step, except for the sustained release or a prolonged action product. This is exception. Integration of a solid drug product is usually more rapid than the drug dissolution and drug absorption. Okay, student, we have learned the rate limiting step and we have learned the three steps: disintegration, dissolution, and absorption. If the disintegration is smart, then the dissolution will be the smart and absorption is excellent. But if the dissolution is poor, then the dissolution will be affected and absorption will be minimal. But keeping in mind, some drugs have been modified, like in case of sustained release or prolonged action product. This smart disintegration um, is not applicable, where we have to slowly disintegrate. Our intention is to slowly disintegration of the formulation is considered. You can see in this diagram the drug in the product. It is disintegrate and the drug liberate in solid drug particle. Solid drug particle when come in contact with the stomach solvent, it makes some dissolution there, drug in a solution, and then some bound and unbound drug available from the absorption is going to happen with the ionized and unionized drug. You people are familiar with the BCS classification. BCS pharmaceutical classification system. According to the biopharmaceutical classification system, drug substances are classified to four classes upon their solubility and permeability. Class 1, Class 2, Class 3, Class 4. Class 1 are the highly permeable, highly soluble. And Class 2, highly permeable and low soluble. Highly permeable. You can see the Class 1 and Class 2. Some examples are mentioned, Class 1 and for Class 2. In Class 1, example are the metoprolol, levofloxacin, and the Class 1 drugs are the compound are well absorbed and their absorption rate is usually higher than the excretion, highly soluble. Class 2 drug, example, levanclamide, cefuroxime. These are their bioavailability is limited by their solvation rate. BCS3 have low permeability and high solubility. Example, cimetidine, and their absorption is limited by the permeation rate, but the drug is solvated very fast. If the formulation does not change the permeability or gastrointestinal duration time, the class 1 criteria can be applied. Class 4, BCS class 4 drug having the low permeability and low solubility. Examples is bifenazole. Okay. It is very important to know about what is highly soluble. Highly soluble according to criteria, a drug substance is considered highly soluble when the highest strength is soluble in 250 ml or less of aqueous medium within the pH range of 1 to 7.5 at 37 degrees centigrade. Substance higher concentration dissolve in 250 ml or less of aqueous medium within the pH range of 1 to 7.5 at 37 degrees centigrade. We say this is the highly permeable. Highly permeable, a drug substance is considered highly permeable when the extent of the absorption in the human is determined to be 90% or more of the administered dose based on a mass balance determination or in comparison to an intravenous dose. Pharmacokinetic, it is defined as the study of the time course of the drug, absorption, distribution, metabolism, and excretion. Clinical pharmacokinetic, as the name describing itself, clinical. It is the application of the pharmaceutical principle to the safe and effective therapeutics management of drug in an individual patient. काइनेटिक्स होगी बट काइनेटिक्स के तमाम चीज़ों को मद्देनज़र रखा जाएगा कि कितनी ड्रग उसके लिए सेफ है और उसके लिए इफेक्टिव है फॉर therapeutic management because as we have learned two different kind of drug may either increase or decrease the effective concentration of any formulation. So it is necessary to know the clinical kinetics of a patient if the polypharmacy is going to manage. Toxicokinetics. It is the application of the pharmacokinetics principle to the design and interpretation of the drug safety evaluation study. These studies are performed in animals during preclinical drug development. Toxicokinetics. Meaning there may be some toxicity related to the higher concentration. Definitely we can't perform or can't give these doses to the human. So first in the preclinical studies, these doses are administered in experimental animal according to their weight and then calculate their toxicokinetics or measure their toxicokinetics. What is the definition of clinical toxicology? It is the study of adverse effect of drug and the toxic substance in body. This is a total introduction of biopharmaceutics. Thank you.